This is an audio-visual presentation on logical reasoning. Now we consider statements. A statement is a verbal or written assertion. When we say verbal, we mean what comes out of the mouth, but written is what we write down. So a statement is either a verbal or a written assertion. A statement can either be true or false. A statement can either be true or false. Example, Accra is in Ghana. This is a true statement. Kumasi is in Togo. This is a false statement. So a statement can either be true or false. A statement cannot be both true and false at the same time. Example, Accra is in Ghana is a true statement. This same statement cannot be false at the same time. Kumasi is in Togo is a false statement. This same statement cannot be true at the same time. So a statement cannot be both true and false at the same time. Now let's look at simple statements. These are some examples of simple statements. Kofi is a bad boy. It's a simple statement. Kofi is a thief. It's also a simple statement. Now let's look at the compound statement. Kofi is a bad boy. It's a simple statement. Kofi is a thief. It's also a simple statement. However, if Kofi is a boy, then Kofi is a thief. It's a thief. This becomes a compound statement. That is, when we put simple statements together, we have what we call the compound statement. So if Kofi is a boy, then Kofi is a thief. This now becomes a compound statement. Now we have what we call negation in logical reasoning. And negations are formed by inserting nots in the statement. Example, when we consider the statement P, Kofi is a bad boy. If you want to form the negation of the statement P, we have to insert nots. And so let's consider the statement Q. Kofi is not a bad boy. So Q is the negation of P. That's when we negate the statement P, we have the statement Q. So Kofi is a bad boy is statement P. Kofi is not a bad boy is statement Q. So we negate P by inserting nots. That is how we form the negation. Now implication. P implies Q. In logical reasoning means Q is true only when P is true. P implies Q means that Q is true only when P is true. Q is true only when P is true. Now let's consider these two statements. Statement P, Abena has measles. Statement Q, Abena is in the hospital. If Abena is in the hospital, then Abena has measles, means that P implies Q. Why? P implies Q means that Q is true only if P is true. Q is true only if P is true. And now statement Q says Abena is in the hospital. And statement P says Abena has measles. So Q is true if only if P is true. Can be written as if Abena is in the hospital. That is statement Q. Then Abena has measles. This means P implies Q. That is, Q is true only if P is true. Now let's look at converse of a statement. Now P implies Q is the converse of Q implies P. Now P implies Q means that Q is true only if P is true. And Q implies P means that P is true only if Q is true. So P implies Q is the converse of Q implies P. Now let's consider these two statements. Abner has measles. That is statement P. Statement Q. Abner is in the hospital. P implies Q means that Q is true only if P is true. And statement Q says Abner is in the hospital. So it means that if Abner is in the hospital, then P, and P is what? Abner has measles. Then Abner has measles. That is P implies Q. But Q implies P means that P is true if only Q is true. Statement P says Abner has measles. So Q implies P can be written as if Abner has measles, then Abner is in the hospital. If Abner has measles, then Abner is in the hospital. Take note that P implies Q is written as if Abner is in the hospital, then Abner has measles. That is, we consider the Q first. Now Q implies P also can be written as if Abner has measles, then Abner is in the hospital. Now let's look at equivalent implication. If P implies Q is true, and Q implies P is also true, then P is equivalent to Q. If P implies Q is true, and Q implies P is also true, then P is equivalent to Q. P is equivalent to Q. Now let's look at the chain rule. P implies Q, and Q implies R. So P implies Q, and this same Q implies R. If it happens like that, then by the chain rule, we can say that P implies R. Why are we saying that? Because here we have P implying Q, and here we have Q implying R. So it means that P now implies R. So R becomes true if only if P is true. Now let's consider the Venn diagram. If P is a subset of Q, so P is a subset of Q, so we can see that P is within Q, and Q is also a subset of R. That is, Q is a subset of R. We can also see that Q is within R. Then we can say that P is a subset of R. P is a subset of R. Let me go over this. Take note of this. P is a subset of Q because P is within Q, as you can see. And Q is also a subset of R because Q is within R. This means that P is also a subset of R because P is within Q and Q is within R. So it means that P is a subset of R. Now let's look at valid arguments. Arguments that are valid. Here the statement can be false, but the argument can be valid. Let's take note of this. Lagos is in Ghana. Ghana is in East Africa. Therefore, Lagos is in East Africa. Now, Lagos is not in Ghana, but that is not what we are talking about. We are talking about the validity of argument, and the argument in question here is therefore Lagos is in East Africa. Now, when you consider this statement, Lagos is in Ghana, Ghana is in East Africa, and therefore Lagos is in East Africa. The argument is valid even though the statements are false. The argument is valid because if Lagos is in Ghana and Ghana is also in East Africa, then it means that Lagos is in East Africa. So the argument is valid. Now, example. Let's look at the statement X. All students are hardworking. All students are hardworking. Statement Y. No hardworking person is careless. Draw a Venn diagram to illustrate the above statement. Which of the following are valid conclusions? Which of the following are valid conclusions? I. Kwasi is a student implies that Kwasi is not careless. II. Asiedu is hardworking implies that Asiedu is a student. III. Ifua is careless implies that Ifua is not a student. Now, solution. Let U be all persons. S equals students. H equals hardworking persons. And C equals careless persons. Now, this is our Venn diagram. C represents careless students. S represents students, and H are hardworking students. Now, from the statement, the statement says that all students are hardworking. That's why S is within H. And another statement says that no hardworking student is careless. It means that H, the circle H and C are disjoint. They don't meet. So S is a subset of H, as you can see. And H and C are disjoint sets. Because no hardworking student is careless. So they have nothing in common. Now let's look at the statement. Kwasi is a student implies Kwasi is not careless. Now, when we say Kwasi is a student, that means that Kwasi is within the circle S. Implies Kwasi is not careless. This is valid because if Kwasi is within S, he cannot be here at the same time. And so if Kwasi is a student, it implies that Kwasi is not careless. It's a valid argument. Now, Asiedu is hardworking implies Asiedu is a student. Now, Asiedu is hardworking means Asiedu can be anywhere within the circle H. But when you say Asiedu is a student, it doesn't sound well because Asiedu can be within the shaded portion. The fact that Asiedu is hardworking does not mean Asiedu is a student because he can be hardworking, but he cannot be a student. He can be outside the circle S. So Asiedu is hardworking implies Asiedu is a student. It's not valid because he can be hardworking but refuse to be within S. He can be where the shaded region. He can be in the shaded region. And so Asiedu is a hardworking implies Asiedu is a student. It's not valid. Now Ifua is careless. That means that Ifua is here. Implies Ifua is not a student. Implies Ifua is not a student, which is true because if Ifua is careless, then it means that Ifua is here. If Ifua is here, he cannot be a student at the same time. So this statement is also valid. This argument is also valid. This argument is also valid. Now, this is the end of our presentation on logical reasoning.